Am I audible to everyone? Okay. Still, lot of people need to join. Right. So in the last class, we have discussed the basics of Hadoop distributed file system and various building blocks of the Hadoop distributed file system and the functionality of those building blocks are also discussed in the last class. So in the Hadoop distributed file system, they majorly wrote it down two important components. One is name node and another one is data node. Name node will maintain the metadata of the entire file system, and the data nodes are physically holds the blocks which are allocated to those nodes, and they will perform the specified operation on it, and finally they produce the results. So Hadoop is able to hold huge volume of data by dividing them into blocks, and those blocks are distributed to the various data nodes. So in such a way, it is able to hold the huge volume of data, and even it is able to process parallelly by distributing those blocks and by distributing those tasks. Okay, so in such a way, it provides a good performance while dealing with the large files. So that is HDFS storage area. Now let us talk about the programming model which is used in Hadoop environment is MapReduce programming model. So in the MapReduce programming model, it is a method for distributing computation across multiple nodes. That means whatever the code that you have developed will be shared with the all the data nodes where the blocks are available, because this code need to be applied on the block. Okay, so that is the reason data node physically holds the data, followed by it also have the process which it will be performed on the data which it holds, right? So that is the reason it is a method for distributing computation. Even the computation process is also be distributed across the multiple nodes. So each node processes the data that is stored at the node. Okay, so it is the responsibility of the data node to process the data. It consists of two phases, as you are aware of that, map and reduce phase. Okay, so these are the some of the map reduce features which we have discussed in the previous class. Okay, now let us talk about what exactly the mapper and what exactly the reducer, and what happens by using these two, what way we can process the data. These things we will discuss in the today's class. So it is operated on key value pair mechanism. Key value pairs mechanism. That means it reads the data as key value pairs. Okay, so whatever the input that you have submitted, from that it will be read the information in the form of key value pairs. Okay, and after that it omits the keys. Okay, we will see while discussing an example of word count how it will be happens. Okay, and it outputs 0 or more key value pairs. 0 or more key value pairs. So the output of the mapper logic is either it may produce 0 key value pairs or any number of key value pairs. There is no limitation for it, right? And then shuffle and sort phase. After producing the results by the mapper logic, the shuffle and the sort phase are executed. The output from the mapper is sorted by key, and all the values with the same key are guaranteed to go to the same machine. I'll show you the diagram so that you can understand. So this is the example diagram. Here you can observe that the input file contains a set of words. A set of words, right? So say for example a Word document. A Word document, when you type something in it, it will be treated as an input to the mapper logic. Okay, so those inputs will be, whenever if you submit an input, what happens in that case, that need to be split into blocks. Okay, so that process is called as splitting. Okay, here you can observe that 3 sentences are present in the file. Let us assume that. So in the first rectangle box, you might have found dear, beer, river is the first sentence, car, river is the second sentence, and dear, car, beer is the third sentence. For example, the first line is split as one block, and the second line is split as second block, and the third line is split into third block. Okay, so these blocks will be always, whenever the file is divided into blocks, those blocks are distributed to the data nodes, right? Because where it is supposed to be stored physically. Okay, say for example, this is the system where this is the data node 1, this is the data node 2, and this is the data node 3, where this mapper logic is executed. As I told you, along with the distribution, processing of the data is also be responsible of data node. So that is the reason the mapper logic is, this is the, whatever you have developed the mapper function, okay, that will be executed in node 1 as well as node 2 as well as node 3. So this is the block which is supplied to the node 1, data node 1. This is the block which is supplied as an input to the, not as an input, just it is the block which is assigned to data node. Okay, so what is the job of the data node here itself? It need to process whatever the block that it was assigned to it. Okay, so in that case, so this what mapper logic here, what way you are supposed to develop the mechanism is, you need to scan this particular sentence and you can found the number of occurrences of the word in a given input. So in our case, we will take only 3 lines. That is the reason you might have observed this is very simple task. But assume that this MapReduce framework or the Hadoop environment is best suitable for large volume files, which is best suitable for just a minute. Roll number 20, 29, 65 and 75. Roll number 20. Please unmute yourself. Roll number 20. Bharadwaj. Roll number 20. 29. 65. And 75. 29. Who is 29? $65. Because you people are belongs to the section 2, but unfortunately you are logged into the section 1. Your class is going on parallelly. You are supposed to log in that particular link. 65. So shall I remove it? Okay. Right. So in real time scenario, the Hadoop will be used for huge volume of data processing, right? So for better understanding, here we consider only 3 lines so that you can easily understand. That is my intention. Right? So whatever block that was assigned to the data node on which this mapper logic, whatever the logic that you have developed will be applied. So here what way you are supposed to develop the mechanism, whatever the input that it receives or whatever the block that it was stored in the data node on which you need to scan the entire file and you need to count how many number of times the word is present in the this particular block. How many, for example, in this case, deer. Okay, so deer is whether it is repeated anywhere, no. So that's why the count of the deer will become only 1. Similarly, beer and river. Okay, so this is the output after processing or after applying map logic on the block which it was stored in the data node. Similarly, for second data node. So in this case, what happens? So this was repeated once and car was repeated once. Like that, initially it counts the words. Okay, just it assigns the count to that each and every word. Similarly, this third one. So now shuffling phase. So what happens in the case of shuffling phase is just simply again we will make it as a all the similar words in a group. For example, in this case, beer. Beer will be repeated 2 times in the outputs produced by mapper logic. So that is the reason beer one will be placed as a first shuffle box. Later, car was repeated 3 times. So that is the reason it was placed at 3 place and deer and river. Okay. And now what reducer phase will do is simply it removes all the data and simply it will be just like it is a consolidation process. So here we found that beer1. Okay, so now instead of writing it as a two different, what it does is simply it will make it as a beer2, and that will be written to the output file. Similarly, this is the block which is supplied to the reducer 2, where it counts all these counts of all these four words. Okay, here the car is repeated 3 times. That's why the count of the word will become 3, and that will be placed into the output file. Similarly, the remaining reducer task. So what reducer will do is simply it consolidates all the outputs produced by the mapper logic, right? So in such a way, the map logic function is going to be executed. Now it is easy to understand what happens. Output from the mapper is sorted by key. Output from the mapper is sorted by key. As you can observe that this is the output produced by the mapper logics. Those will be ordered by key. That means alphabetic order B. Starting letter is B, and whatever the words which are present with the starting letter B will be placed here. C, D, next R. So, and all values with the same key are guaranteed to go to the same machine. All values of the same key are guaranteed to go to the same machine. Same machine in the sense where the reducer is working. All right. And coming to the task of the reducer, it called once for each unique key. Unique key in the sense here the word. It called once for each unique key. It gets a list of all values associated with the key as an input. As you can observe in this diagram, okay, single key, and all the those values are submitted as an input to the reducer, and gets the reducer outputs 0 or more final key value pairs, usually just one output per input key. That means suppose along with the beer, suppose some other words are also be submitted to this particular one, some ZX1, imagine some Zoom1, Zoom2, Zoom3, like that. Okay, so in that case it will produce two different outputs. Beer 2 times repeated, Zoom was repeated 3 times, like that it is supposed to produce. Okay, so that is it. Suppose in such a way the reducer is going to produce the output. So this is about what way you are supposed to develop the map reduce logic. Okay, so here what way you are supposed to generate this output, that is up to you. You can write your own way to develop the code which can produce these kind of results. And similarly, reducer logic also. Here we are supposed to develop the mapper logic and the reducer logic. Okay, just two functions we are supposed to define. If you want, I'll show you the example program. Of course, we will discuss that one also. First, for better understanding, I'll show you the example program. Is it visible to everyone? My screen is visible or not? My screen is visible or not? Okay, okay. All right. See, here you can observe the same example. These are the two input files which I was applied to the mapper logics. Okay, and they will produce the final result like this, right? For that, what way we have developed the program is, so here you can observe that the name of the program is word count. Don't worry about all these things. We will discuss all these things in detail. Okay, just for showing you what is the code that we are supposed to be develop. For that purpose, I just shown you this particular example, right? So this is here. You can observe that public void map. Okay, so this is the mapper logic which we are going to be develop. Okay, and similarly This is the reducer logic. Okay, that's it. These are all the main program. What way? These are the some of the essential things that are common for every program. These are all the essential things for every program, every MapReduce program. So don't worry about all these things. We will discuss about all these things in detail in the later sessions. So this is the simple program which counts the number of the word count of the input file which you have supplied. So see here how many lines we have written as a code. Only this is the declaration part. So this is only the thing which we have developed. Only 3 lines of code. Similarly, the reducer. So don't be get confused or don't be excited like sir, we are supposed to write huge lines of codes. Not like that. It depends upon your analytical skills. What way you are able to analyze the problem and what way you can develop. Uh, that all depends. So you can easily develop the MapReduce programs because you are all good in Java, so that you can easily develop the programs and you can execute it. Okay, so don't worry about it. Now, once again, we quickly reveal the what are the components which are present in the Hadoop environment. That means HDFS, through which how we can process the data. So, as you all aware of that, name node, it holds the metadata for the HDFS. Secondary name node performs housekeeping functions for the name node. Just it maintains the backup of the name node. And data node, it stores the actual HDFS data blocks. Okay, and HDFS data blocks. First point, storage area, and task tracker. Task tracker is also with a component which will take care of processing the data which is stored at data node. So that's why task tracker is also be executed in data node. Okay, so that means if you supply the mapper logic and reducer logic, those will be executed on the data block which it was stored in the data node. So that will be taken care by task tracker. And job tracker. Job tracker manages MapReduce jobs. That means distribution of the data blocks and supervision, listening the heartbeats. These all things will be taken care by job tracker. So job tracker will be present in the name node itself, right? So these are the essential building blocks of HDFS. So whenever if someone asks you the question, you are supposed to explain all these 5, right? Once again, you are all aware of all these things. You just try to reveal yourself what exactly the name node that you understood and all other parts. So the name node stores the HDFS file system information in a file called FS image. As we have discussed in the last class, the transaction log will be stored at edit log, and the file information will be stored in the file FS image file. Okay, updates to the file system, add, remove blocks, do not change the FS image file. They are instead written to a log file. Okay, they are all modifications will be stored in log file. Okay, when starting the name node loads the FS image file and then applies the changes in the log file. Suppose whenever if you modified a file, okay, first the FS image is the basic information which is available with the name node. First that was loaded and it verifies with the log file where the modifications are available. Okay, whenever if you did any modifications on the file, so those files will be updated in the FS image file. All right, and secondary name node, not a backup for the name node. Backup for the name node in the sense, as I told you, it won't act as a name node when it gets failed, right? Just simply whatever the essential functionalities that the name node has to do, those will be performed by secondary name node. Don't be confused here itself. As I told you, which maintains a backup. Okay, so backup in the sense, whenever if it was stopped, it won't take any chance to acts as a name node. Just it maintains the information regarding the essential functionalities of the name node itself. Okay, So periodically reads the log file and applies the changes to FS image file, bringing it up to date. Now you can understand here how it keeps the FS image file as an updated one by doing this particular activity. Okay, so that means whenever if the name node gets failed, what happens? You need to restore the data. So from where you are supposed to restore the data? From the secondary node itself. Okay, this will need to be what it contains, the updated FS image file. So if you have the FS image file, what you will have, you have the complete information regarding the file system itself, right? Because FS image stores the HDFS file system information in FS image file. So that is the reason whenever if you have updated FS image file, it indicates that you will have complete information regarding the file system. All the files which are stored in HDFS, and allows the name node to restart faster when required. Right? Whenever if you are restarting the name node, in that case, by loading this updated FS image file into the name node, so that it helps the name node to restart within no time. So job tracker and task tracker. Job tracker determines the execution plan for the job and assign individuals tasks. As I told you, those blocks of the blocks distribution and the map reduce job distribution will be done with the help of job tracker itself. And task tracker. So keep tracks of the performance of an individual mapper or reducer. This is going to be executed in the data node level, where it supervises the execution part of the mapper logic or the reducer logic at a data node. Why we are calling it as a data node? Because there the physical data or the block data is available in a data node. So that is the reason it should be available at a data node. Right? So other tools which are available with the MapReduce is Hadoop ecosystem is Hive. This which we are going to discuss in the fourth unit, not fourth, fifth unit. Hadoop processing with SQL, just like it is an SQL queries which is used to process the Hadoop data. And Pig, this is also be the sixth unit. Pig, Hadoop processing with scripting. It is a Pig Latin is a scripting which is used to process the Hadoop data. Okay, these two we will discuss in the sixth unit. And cascading is piping and filtering processing of a model. That means you filter the data and make it in a file, especially while handling the streaming data. Okay, by using different programming languages like Python, other scriptings. Okay, so in that case, we'll use this particular tool. And HBase is just like database for the Hadoop. It acts as a database for Hadoop, and it can be implemented in different ways. There are column-oriented, document-oriented, like different formats of databases are available. Okay, and Flume, designed for large-scale data movement. So these are only the few other tools which are used in Hadoop ecosystem. Not only this, it was restricted. These are the major categories of tools which are used with Hadoop. Right. So this is about Google file system, HDFS, and MapReduce framework. Do you have any queries up to now? Do you have any queries? If you have any queries, I'll answer it. Otherwise, I'll move to the configuration of Hadoop. Configuration of Hadoop. So shall I continue with that? Or you have any queries? So today's absentees are B2, G2, LE 504. Okay. So let me discuss the configuration of Hadoop. As I told you in the previous classes, Hadoop can be configured or installed in three different modes. One is local or standalone mode. Second one is pseudo distributed mode, and third one is fully distributed mode. Okay, so these are the three different modes we can operate Hadoop in our system, right? Okay, so now let us see the configuration. Actually, if the prerequisite for the installation of this Hadoop in your systems is you should have, because the entire framework is developed using Java. So the yes, three doubts. E5, E5. E5, unmute yourself. E5. E5, unmute yourself. Right. So, so that is the reason wherever you want to install the Hadoop, you are supposed to install Java. And usually, Hadoop is best suitable in Linux environment. In Linux environment, of course, it is also be executed in Windows environment also, but it is best suited for execution in Linux environment. So now keep it up these 2 points in brain. We will try to install the Hadoop in three different modes: standalone mode, pseudo distributed mode, and distributed mode. Okay. In the standalone mode, both name node and data node are running a single system with single JVM. Okay. Whereas in the pseudo distributed mode, there also the name node and data node are running in the same node, same system or single cluster, where it uses different JVMs for executing a process. So it uses more than one JVM for its process, whereas standalone mode it uses single JVM. That is the difference between standalone mode and pseudo distributed mode. In both the cases, we are able to execute our MapReduce program. Okay, but the way which it process is different. Okay, so usually we will use these two models for debugging. That means where you have developed your application and you'll try to test whether the application is produced desired outputs or not. That task will be done with the help of any one of these three modes. By default, the Hadoop is installed in standalone mode. If you want to change it to the pseudo distributed mode or fully distributed mode, you are supposed to change some configuration. Okay, the configuration management, I mean, those configuration files are XML files, core site.xml, yarn.xml, yarnsite.xml. See how to modify those XML files. That is called as configuration of XML files also. Okay, so let us talk about the steps for installation of Hadoop in standalone environment. Okay, so you just read these statements. Before installing Hadoop Linux environment, we need to set up the Linux using SSH, secured shell, because we will try to connect securely from an unsecured line to secured environment. So here we will use the public key cryptography algorithm RSA. Hope you are aware of it or not. I don't know. Do you know the different two categories of cryptographic algorithms? That is symmetric and asymmetric. Symmetric and asymmetric. Symmetric and asymmetric. Anyone of you please respond? Ravan? Yes, Vijay Ravan. Are you present or not? Yes, Vijay Ravan.
Present, sir.
Unmute yourself.
Sir.
Yes. Do you know the symmetric cryptographic algorithms? Whether it is over or not in CNS subject?
Algorithms somehow completed, sir.
Symmetric is completed or not?
Completed, sir. I guess.
Okay. Do you heard about RSA algorithm in CNS?
CNS RSA algorithm, yes, sir.
Is it completed or not?
No, sir.
Okay. Okay. Fine. You can unmute yourself. All right. Thank you. So here we will use the public key cryptographic algorithm RSA for implementing the secured communication between unsecured terminals to the secure. So because without having the security, what kind of problems that we are going to be faced, you might have studied in you are going to study in CNS subject, right? So here we will use the RSA algorithm for the generation of keys which are used for exchanging the information between two terminals, right? So for that purpose, here we'll create the secured shell. So these are the following. These are the steps which we are supposed to follow while installing the Hadoop. First, we are supposed to create the user, where because you are the user, you are going to be create you are going to submit your inputs, and you are supposed to get the outputs. So for that purpose, initially we need to create the user. So for that, what is the first task which we are supposed to do is we'll move to the root directory. That means super user directory, SU. That means when you are open your command prompt, you are somewhere. Okay. What happens when you want to move to another location? You are supposed to specify to where you wanted to move. In the similar way, here we need to move to the location root plus SU, and you can set the password for it also. After that, you can add user add Hadoop. This is the command user add. This is the command used for adding user to the Hadoop environment, and you can set the password for it. Okay, so you can generate the password for it. So in that, after executing these commands, what you will get is you are able to create a user. Okay, and you can set password for it. All right. Now, so this is the important part where, as I told you, we'll use the public key cryptographic algorithm RSA for the key generation. Okay, SSH setup is required to do different operations on clusters such as starting, stopping, distributed domain, shell operations to authenticate different users of Hadoop. Okay, so for all these authentication processes, we need to have a cryptographic algorithm. Okay, so for that purpose, we will use public key cryptographic algorithm. So in the public key cryptographic algorithm, every node has to generate two different keys public key and private key. Okay, the public key, that means every system need to assume keys. One will be considered as a public key and another one will be considered as private key. So all the public keys need to be placed in a common place called public key ring. Okay, whenever if a sender wants to transmit some data to the recipient, always the sender has to search in the public key ring of where the recipient's public key is available, because the sender has to encrypt the data with the help of recipient's public key. With the help of recipient's public key. So that is the reason it always, whenever if A wants to send data to the B, always A need to search for the public key of the B in the place public key ring. Suppose if it is not available, the public key of B is not available in the public key ring, then there is no communication exists between A and B, because the encryption process in the public key cryptographic algorithms will be done with the help of public key of the recipient. Okay, unless until it is not having the public key, it is unable to communicate with others. So that is the reason whenever if a system wants to participate in this kind of communication, it need to assume two keys. One will be kept as public key and another one will be kept as private key. So whatever the key that it is assumed as a public key, that need to be placed in public key ring so that it is get communicated with others. Okay. So in the public key cryptographic algorithms, we need to generate two keys. One will be kept as public and another one will be kept as private. Okay. So by using recipient's public key, the sender can encrypt the data by using that public key, and those data will be transmitted over the network. Whenever the recipient receives it, okay, that will be decrypted with the help of recipient's private key. So that is the reason here for the encryption we are using public key, for decryption we are using private key. So that is the reason in this case we are using two different keys for encryption and decryption. That is the reason why we are calling it as a asymmetric cryptographic algorithm. Asymmetric, symmetric. Symmetric means shared key cryptography. For both encryption and decryption, if you are using the single key, then it is called as shared key cryptography or symmetric cryptography. If we are using two different keys, one is for encryption and another one is for decryption, such kind of algorithms are called as asymmetric cryptographic algorithms or non-conventional cryptographic algorithms. Right? So here we will use RSA algorithm, which is a key exchange algorithm. RSA stands for Rivest, Shamir, and Edelman, three gentlemen who have developed that algorithm. The starting alphabets of three gentlemen who have developed that algorithm, RSA. Here we will use that algorithm. So here the first statement SSH key is an RSA, right? So it generates the, and whatever the keys that are generated, you can display it here itself, authorized keys. And chmod, which is the command for authenticating users, right? So by using this command, you can create the keys for your authorization process of this particular user. Whenever if you submit something, okay, along with these keys will be supplied for the authorization process, right? So that is about the user. Don't worry, whenever if the college reopens, we will see physically how it is going to be installed, and in the lab sessions you can practice some of the important programs on this particular environment. Of course, meanwhile we will try to create a virtual lab where you can practice. So I don't know how far we would stay in that area, but we in the process of creation, right? But you should aware of how to install this Hadoop in your environment and how you can run your programs. These things you are supposed to be aware of. So that's the reason we need to be discussed here. So installing Java, as you know how to install the Java and all, because you are familiar with this. After installing the Java, you just verify Java is installed in your system. Now let's start the actual installation of this. So download JDK visiting the following link. Okay, oracle.com, where you can download the GK, and generally you will find the downloaded Java file in downloads folder. Verify it and extract the JDK file using the following commands. These are the commands which are used to extract the JDK from the downloaded program. Right? Usually these are the tar files, tab of archive files. Just like WinZip, you can imagine it's a WinZip, because if you make it as a tar file, which is easy to transmit the data over internet. So that is the reason it was created as a tar file. Okay. And step 3, to make Java available to all users, you are supposed to move it to the location user local. So this is the common place which can be accessed by all the. So how do we move it to the user local? Is you just open the root and you can add. I mean, you just go to your user. SU is the root, and where this is the password you are supposed to be entered in the creation of the first step here itself. Okay, before adding the user, here we go to the root. For that, we have created the password. We just simply use move this so and so file to the location user.local, and then exit. And next, step 4. As you know, whenever if you want to execute the Java programs, you are supposed to set the path and the environment variables. Usually we did it in the Windows environment. We'll go to the properties of the computer where we can set the environment variables. There we'll mention the path of the. So similarly here also the export Java home and export path where the Java is available. Okay. Now apply all the changes into the current running system. So this is the bash file. So where all the information regarding this current user is available. Okay. Use the following commands to configure Java alternatives. Of course, this you can do, which will be automatically done while installing Java. And next, now downloading of Hadoop. We just download the Hadoop from this website. Okay, you just move to your local environment and you can start downloading, because this is the area place from where you will keep all your software. Previously, we have moved our Java into user.local environment. Now also, we'll try to install, we'll try to place our Hadoop software is also in the same location. And it is a, you can imagine it is a WinZip file. You are supposed to extract those files. Okay. So for that, we need to do all these steps. And after that, we'll exit from it. So Hadoop distribution modes we have discussed. Now, how to set up the Hadoop. Okay. Now, you can set Hadoop environment variables by appending the following commands. So because this contains the bash RC configuration file contains the information regarding this user, and so before proceeding further, you need to make sure that Hadoop is working fine, whether it was successfully installed or not. For verifying those things, for every software it was installed successfully or not, you need to verify the version. So Java version, Hadoop version. Okay. So if you type this command, it will be displayed the following information. So checksum and all the information will be Hadoop version is displayed, so that you can understand that Hadoop is successfully installed in your environment, right? So you can create your own input directory. You're supposed to create an output directory where you want to keep your files. And remember that always we'll try to execute the jar file which was created. Okay, so Java runtime environment, because here we'll use the single JVM, where in pseudo distributed mode or fully distributed mode, we'll use multiple JVMs. So always we'll run the jar file for getting the outputs. Don't worry about it. We'll see how to execute, how to create, and all the things. But initially, it may be difficult to you to understand what exactly all these things. But when you start practicing, you'll be clear with all these things, right? So this is the way you can install the Hadoop. And always you need to create two different directories. One is for input and another one is for output. Meanwhile, we'll compile the MapReduce program and we'll create the jar file and we'll run the jar file so that the output will be placed in output.txt. Okay. So this is about installing Hadoop environment. In the next class, we will see the installation of Hadoop in pseudo distributed mode and as well as fully distributed mode, and how to configure the XML files also. Okay, so that's it. Any queries? Do you have any queries? Anybody? Okay. I will end the session and we'll meet in the next class. Thank you.